Hello everyone. So we are discussing now about uses of dimensional analysis. So in the first one we have discussed how to check the correctness of an equation. That is, all the dimensions, they must be the same. Or if they are not same, it means the formula is wrong. Okay? So there are three uses. One is done. In this class we will discuss about other two uses. So the second one is to convert one system of unit. Just a minute. Conversion to convert one system of unit, suppose say MKS, CGS or SI, to convert one system of unit into another system of units, to another system of units. Okay? Suppose for example, one quantity is given, suppose in your SI. Then conversion of SI to suppose CGS, conversion of suppose SI to MKS, conversion of suppose MKS to SI, conversion of any other system of unit into another system of unit. So let us move back to our first class. I have given you that physical quantity, suppose the quantity here is mass. Physical quantity is mass, and the mass of an object is equal to suppose 5 kg, and in 5 kg can be written as 500 gram. This is SI and this one is CGS. Okay, in both the cases the quantity is the same, mass 5 kg and 500 gram, both are the same. So I have given you a formula that Q is equal to N1U1 into N2U2. So when there is a change in the unit, there is a change in the number also. Dekho, you have changed the unit from kg to gram, so there is a conversion of number from 5 to 5000. Okay, but quantity is the same, that is 5 kg or 500 gram or 5000 gram, both are the same. So unit, this is another unit. Okay, so in one system of unit, suppose the quantity Q is having a dimension N1, the number 5 or 5000, it has no dimension, na? So the dimension is suppose M1 to the power A, L1 to the power B, and T1 to the power C. We can write up to only 3. What is the power of mass A? What is the power of length B? What is the power of time is equal to C. So in one system of unit it is equal to this much. In another system of units, the same quantity can be written as, a number will be there, na, N2. So N2 will be there, but there is a change in the unit. So M1 will be changed to M2. But is there any change in power? No. So it will be M2 to the power. देखो kg था, क्या यहाँ पे ये ग्राम स्क्वायर बन गया? नहीं, यहाँ पे kg था तो यहाँ पे ग्राम, दोनों में पावर कितना है? 1. The power will be the same, but there is a change in the unit. So it will be L2 to the power B and T2 to the power C. Okay? This is one system, this is another system. But we know that N1U1 is barabar to N2U2. It means N1, M1 to the power A, L1 to the power B, T1 to the power C, and 2 m2 to the power a, l2 to the power b, T2 to the power C. Same, N1 U1, N2 U2. So what is the number? N2. N2 will be N1. It will be M1 to the power A, L1 to the power B, T1 to the power C, M2 to the power A, L2 to the power B, T2 to the power C. Okay? Simply the cross multiplication. So it can be written as N1 M1 by M2 to the power A, क्योंकि दोनों का पावर बराबर है. Okay? Then L1 by L2 to the power B and T1 by T2 to the power C. This one we can use as a formula. Okay? But remember one thing, we have to limit our dimension till M, L and T only. We cannot use temperature there. We cannot use ampere there. Okay? So this is limited up to M, L and T only. So this is a kind of formula type. So let us do an example. Let us do an example. So what is the SI unit of force? The SI unit of force is Newton, and we have to convert it to CGS unit. So question is 1 Newton is equal to dash dyne. What SI unit of force is Newton and CGS unit of force is dyne. So you have to show that what is this value. मतलब इस पे वैल्यू कितना आएगा, 1 2 3 4 5 6 कितना आएगा. ठीक है. What is this? This is the unit of force. This is also unit of force. Okay. So this unit, Newton is for SI and dyne is for CGS. Both are the unit of force. So the first thing is, what is the dimension of force? First we have to find out that what are the physical quantities involved. M, L, T minus 2. So what is the value of A? 1, 1. So the value of A is 1. Value of B is also 1. And value of C kitna hoga? C will be minus 2. So this is N1 is equal to what? 1, N2, that we have to calculate. So N1 is equal to 1, M1. This is SI unit, na? So what are the physical fundamental quantities involved in this one? Force, mass, length and time. So mass का unit क्या होगा SI पे? First this is SI. So this is the process, huh? L1 is equal to 1 meter and T1 is equal to 1 second. So this is in SI. Okay? We are converting SI system into CGS system, na? So in CGS, what is the number that we want to calculate? What is the unit of mass in CGS? 1 gram. So this is 1 gram. What is the unit of length? 1 centimeter. What is the unit of time in CGS? Is equal to 1 second. Tabulation is done. Okay? Now we will put in that formula. এতিয়া আমি সেই ফৰ্মুলাটোত বহাই দিম to calculate N2. So this is the formula here. So N2, what is the value of N1? 1. अच्छा M1 किमान? What is the value of M1? 1 kg. This is 1 kg by 1 gram. A is 1. L1 is 1 meter by 1 centimeter. 1. Time is 1 second. 1 second minus 2 cancel. Achha, 1 kg is equal to how much gram? This is 1000 gram. So we can write 1000 gram by 1 gram. 1 का कोई काम नहीं है, तब भी लिखो. 1 meter is 100 centimeter by 1 centimeter to the power 1. Centimeter cancel, gram cancel. 10 to the power 3 and there it is 10 to the power 2, so it will be 10 to the power 5. So what is the value of the N2? So in our answer we have to write that 1 Newton is equal to 10 to the power 5 dyne. This is the answer. So we have converted the SI unit of force, which is Newton, into dyne, and 1 Newton is equal to kitna dyne? 1 Newton is equal to 10 to the power 5 dyne. So by using that formula we have to solve. Acha, let us do one more example. That is, show that 1 joule is the SI unit of work done. What is the CGS unit of work done or energy? 10 to the power 7 arg. This is arg, huh? So joule, this is in SI system and arg is in CGS system. Joule is the unit of energy, or you can say work done. This is energy, or you can say work done also. Energy oblique work, कुछ भी कह सकते हो, ठीक है? So how we will show it? If N2 is equal to 10 to the power 7, then this formula, this equation or this conversion will be valid. Okay? So let us try to do the conversion. इसको try करते हैं, ठीक है? I am not going to erase the formula because this formula will be used. देखो फिर से solution, इसको हम कैसे proof करेंगे, ठीक है? So this is the unit of work done. So first you have to find out the value of A, B and C. So work done is M L2 T minus 2. So the value of A is 1, B is 2 and C is minus 2. Okay, A1, B2, C equal to minus 2. Done. So we have to convert SI. So in SI the value of N1 is equal to 1. Here number is 1. In SI, acha, what are the quantities involved? Mass, length and time. 1 kg. In SI length is 1 meter. Time is 1 second. So we are converting SI to CGS. So in CGS, N2 is given as 10 to the power 7, but we have to prove it, na? So N2, suppose we do not know. M2 is equal to 1 gram, L2 is equal to 1 centimeter, T2 is equal to 1 second. If N2 अगर 10 to the power 7 आ गया ना, तो हम लोगों का ये आंसर सही हो जाएगा. अब देखो, what is the value of N2? N1 is equal to 1. और ऐसा भी हो सकता है कि so that suppose 10 joule is equal to 10 to the power 8 arc. Then what is the value of N1? 10. थोड़ा इस बार मैंने थोड़ा चेंज कर दिया है, ठीक है? तो N1 is equal to 10, M1 is equal to 1 kg divided by 1 gram. This is 1. 1 meter by 1 centimeter. B is 2. And it is 1 second by 1 second, power is minus 2. Okay, so here it will be 10, 1 kg is 1000 gram by 1 gram to the power 1. This is 100 centimeter by 1 centimeter to the power 2 into 1. Gram gram khatam, centimeter centimeter khatam. So it will be 10 into 10 to the power 3. Yeah, 100 square. 100 is what? 10 square. So 10 square to the power square kitna hoga? 10 to the power 4. So this is 10 to the power 8. So what is the value of N2? 10 to the power 8. So from here what you can write? You can write 10 joule equal to 10 to the power 8 arc. Bas, this is the way to use the second one, okay, conversion of one system of unit into another system of unit. Now we will move into the third one. थर्ड वन पे अभी हम लोग मूव करेंगे, ठीक है. दैट इज टू डिराइव ए फिजिकल क्वांटिटी. थर्ड वन इज टू डिराइव द रिलेशनशिप बिटवीन वेरियस फिजिकल क्वांटिटी. मतलब टू एस्टैब्लिश ए relation between different physical quantity. For example, mass and acceleration. What is the relation between mass and acceleration? F equal to ma. So we have to show that F equal to ma. We can show that by using dimensional analysis. Okay. It is the third uses. Okay, so let us do the third one. To derive the relationship between various physical quantity. To derive the relationship between various physical quantities, okay, or you can say to establish a equation within bracket, to establish an equation. আমি সমীকরণ এটা আমি প্রুফ কৰিব লাগে, ওকে. আচ্ছা, মই ফাৰ্ষ্ট কৈছিলোঁ যে ফ'ৰ্চ ডিপেণ্ডছ অন হোৱাট, মাছ এণ্ড এক্সিলাৰেশ্যন. চ' এইটোৱে বাৰু আমি ফাৰ্ষ্ট কৰোঁ, প্ৰচিডিঅ'ৰটো চাবা কেনেকৈ কৰিব লাগে. ছাপ'জ আমি এনেকৈ ক'লোঁ যে ফ'ৰ্চ এক্টিং অন এন অবজেক্ট depends on force acting on an object depends on, suppose আমি এনেকে কলো mass m and acceleration a of the object, ঠিক আছে, of the object, show that f equal to ma. তো আমি ডিপেণ্ড কৰে, চ' আমি প্ৰুফটো কেনেকৈ কৰিম চোৱা. চ' কি দিছে, ফ'ৰ্চ ডিপেণ্ডছ অন মাছ. তো এফ ইজ প্ৰপৰ্চনেল টু এম টু দি পাৱাৰ এ. মাছৰ ফৰ হাউ মেনি টাইমছ অফ মাছ উইল বি ইনভলভ হিয়াৰ ডেট উই ডু নট ন', চ' এম টু দি পাৱাৰ এ. অলছ' ফ'ৰ্চ ডিপেণ্ডছ অন एक्सीलरेशन टू दी पावर बी. ओ 2a हो गया ना, तो इसको सपोज m टू दी पावर x एंड a टू दी पावर y. मतलब मास इज इन्वॉल्व हियर फॉर सपोज x टाइम एंड एक्सीलरेशन इज इन्वॉल्व हियर फॉर सपोज y टाइम्स. ओके, सो आफ्टर कंबाइनिंग वी कैन राइट m टू दी पावर x, a टू दी पावर y. फ्रॉम हियर f इक्वल टू k m to the power x, a to the power y. k is a डायमेंशनलेस कांस्टेंट. मतलब k जो है उसका कोई डायमेंशन नहीं है, मतलब इट इज ए नंबर. सो k इज ए डायमेंशनलेस कांस्टेंट. तो व्हाट विल बी द डायमेंशन ऑफ फोर्स. देखो ये इक्वेशन पे अभी ध्यान देना. हाँ, सो वी कैन राइट व्हाट इज द डायमेंशन ऑफ फोर्स, m L T minus 2. K, it has no dimension. What is the dimension of mass? The dimension of mass is m to the power x. Dimension of acceleration is L T to the power minus 2 into y. So it will be m to the power x, L to the power y, T to the power minus 2y is equal to m L T to the power minus 2. तो कंपेयर करो दोनों साइड. इस पे कितना है 1, तो x का वैल्यू कितना होगा 1 और y का भी वैल्यू कितना होगा 1, ठीक है। कंपेयर करो, देखो m टू द पावर 1, m टू द पावर x, तो x विल बी व्हाट 1, y इज इक्वल टू 1, माइनस ट्वाइस y इक्वल टू 2, माइनस माइनस कैंसिल, सो y इक्वल टू 1. So put in this equation, this is equation number 1. So equation 1 implies f equal to k m to the power 1 a to the power 1. So f equal to k ma. So k is equal to 1 here experimentally. This is from experiment. K is equal to 1. So the formula will be f is equal to m into a. So in this way we have to establish the relation among various physical quantity by using the third uses of dimensional analysis. Okay, so we will solve a problem from your textbook now. This is the first one. Now we will go for solving another one. These will be from your textbook, huh? So I am not going to write the question. I will tell you. So example number 2.17. Example 2.17. Example 2.17, page number 33. So what is given in the question, देखो, consider a simple pendulum, you know pendulum, ठीक है, having a bob attached to a string that oscillates under the action of force of gravity. Suppose the period of oscillation depends on L and mass of the bob and acceleration due to the gravity. Derive an expression for its time period using the method of dimension. So it depends on L, M and Z. Okay, so we have to find it out. देखो, time period is represented by time period. Time period माने অসমীয়া হৈছে পৰ্যায়কাল, हाँ. So time period of a simple pendulum depends on length of the pendulum. So L to the power a. For how many times L will be involved? L to kiman times thakibo? To the power 1, minus 1, 2, 3 ami nazanu. So we have given this value as a. Acha, it depends on mass buli koise. So m to the power b. It depends on z to the power c. Okay? It depends on g to the g. So this one. So from here we can write t is proportional to L to the power a, m to the power b, z to the power c. From here t is equal to k, L to the power a, m to the power b, z to the power c. K is a dimensionless constant, huh? Time period is what? It is in always seconds, so the dimension of time period will be capital T itself. Okay, K is a dimensionless constant, no dimension. Length का dimension होगा L to the power a, mass का dimension, this is capital M, हाँ, to the power b. Acceleration due to gravity is what? Meter per second square, na? So it will be L t to the power minus 2c. So it can be written as, in the left hand side, m0 L0 t, क्योंकि m और l लेफ्ट साइड में है नहीं, राइट साइड में m टू दी पावर b, l टू दी पावर क्या होगा, देखो यहाँ पे l टू दी पावर a है और यहाँ पे l टू दी पावर c है, तो इट विल बी l टू दी पावर a प्लस c एंड t टू दी पावर माइनस ट्वाइस c. अब दोनों को हम इक्वेट करेंगे, यहाँ पे b है, यहाँ पे 0 है, तो व्हाट इज द वैल्यू ऑफ b? b will be equal to 0. A and minus twice c, t to the power what? 1. So minus twice c is equal to 1. So c is minus half. Done. And a plus c is equal to 0. A plus c is equal to 0. L का power 0 है. From here a will be minus c minus minus half is equal to plus half. So we got B0, C minus half, A plus half. So this is equation number 1. So equation number 1 implies T equal to K L. L to the power A, what is the value of A? Half. M to the power B means M to the power 0. Z to the power minus half. It can be written as K root over L, M to the power 0 is 1, and it will be what? It will be 1 by G to the power half. So this is K root over L into 1 by root over Z. So K root over L by Z. What is the value of K? K is equal to twice pi. This value you will get experimentally. So K equal to twice pi. So the equation will be T equal to twice pi root over L by Z. So this is the time period of a simple pendulum. This is with the help of dimension method. We will derive the same equation in our last chapter, that is in wave, with the help of equations. No dimensional method will be there. With the help of normal equation we will solve. So these are the 3 uses of dimensional analysis. Okay, so you open your textbook, some examples are there, take some reference book. Okay, and in your reference book lot of examples are there, numericals are there, so try to solve few numericals from your textbook also, and your reference book also, prefer some reference books. Okay, in our next class I will try to provide you some best reference book. Okay.